Then when we go to the equation part, we'll discuss about that more. Like I told about Michaelis and Menten, these are the two people who worked in, these were the two of them, they worked, then finally we got the equation. And we'll go to the equations. Also, now you can see the slides, I hope. So in the slides, you can see there are enzyme, which I mentioned in blue color, and there are substrates. So this substrate will bind to enzyme and form enzyme substrate complex, and finally the products will go and enzymes are recycled back to the initial state. That means we are not losing enzyme at any stage, we are getting them back and performing the reactions after reactions and reactions, and our body will kill those enzymes when it reaches its half-life. When it reaches its lifetime, those enzymes are subjected to what you call senescence, are subjected to degradation by the protein degradation machinery in us, because most of the enzyme what you see in our body, it's protein. So enzyme bind substrate and form enzyme substrate complex. That forming enzyme substrate complex is so important in maintaining or to form the product. And finally, products are released, enzymes are recycled back. If you write this in equation format, you will get equation like this: E plus S, that means enzyme plus substrate, is equal to enzyme substrate complex, or enzyme substrate binds and forms enzyme substrate complex. So that is vice versa, reversible reactions. That means enzyme and substrate can form enzyme substrate, enzyme and substrate can dissociate and form enzyme and substrate. Both the possibilities are there. Then enzyme and substrate, once it forms enzyme and substrate, if complex, then it can form enzyme plus a product. This is the equation what we can derive from. This is a first order kinetic equation for enzymatic reaction. If you solve this equation further and further and further with your logical mathematical skill, you will get this equation. Both the equations, I have mentioned two equations here. One is V naught is equal to Vmax into S divided by Km plus S. Vmax into S is in the numerator, Km plus S in the denominator. That means V naught, the velocity of a reaction, is equal to maximum velocity at the initial scale into substrate concentration divided by Michaelis-Menten constant plus substrate concentration. Or else it can also be written as V naught is equal to Vmax into S naught divided by Km plus S naught. Both the possibilities are there. That means either you can write it as a V naught and S, or else you can write it as a V naught and S naught. So you might be thinking, what is the difference between S and S naught? S means the substrate concentration, and S naught means substrate concentration at the initial stage. When you're just starting the reaction, what is the substrate concentration? V naught is also same, the velocity of the reaction at the initial stage. And Vmax is also same, maximum, that means initial maximum velocity of the reactions. So V naught means initial velocity of the reaction, S is the substrate concentration, S naught is the substrate concentration at the initial level, then Vmax is the maximum velocity, Km is a Michaelis-Menten constant. It can be clearly written as a Michaelis-Menten constant, or else a substrate concentration when V naught is half Vmax. I hope you are getting the things. V naught means initial velocity, S means substrate concentration, Vmax is maximum velocity, and Km means Michaelis-Menten constant. And Michaelis-Menten constant can also be written as substrate S is equal to Km when V naught is equal to Vmax. That is the important thing we have to solve in the later part of it. So I hope when enzyme react with substrate, it forms enzyme substrate complex and product. So if you solve that equation, you will get Michaelis-Menten equation. The Michaelis-Menten equation says V naught is equal to Vmax into S naught divided by Km plus S naught. S naught means substrate concentration, Vmax initial maximum velocity, V naught means initial velocity, and Km means Michaelis-Menten constant. Michaelis-Menten constant means MM constant we call. Michaelis-Menten constant means a substrate concentration at V naught is equal to half Vmax. Or else I'll show in next slide, there it is clearly written. So next slide, in the coming slide, I'll show you that. But this is the derivation for Michaelis-Menten equation. And finally, you will get this what equation I written in the bold format. So we are not worried about this because there are assumptions are done, the mathematical logics are applied, and finally you will get the equation. Those part we are not going to study in your enzymology. Just these equations are sufficient. And there I mentioned one word called steady state. Steady state means in steady state kinetics, when substrate concentration is more than the enzyme concentration, then we can apply this assumption and solve this equation. Steady state assumption application means when substrate concentration is more than the enzyme concentration at the initial stage. Because this is all theoretically done, this is not practically done, but the theoretically done to derive an equation for first order kinetics of enzyme reaction. So this final boldly written equations are so important for us, not the remaining derivations. When you go for higher studies, or we may get extra classes, maybe theory class in regular colleges, a regular class in the college, then we can go about derivation can be done. But in the online mode, it is very difficult to do the derivation. So I'm not going to touch a derivation part. I'm just emphasizing only on the final equation needed to solve or else to write the Michaelis-Menten the equations. So this is what I told. What is Michaelis-Menten constant? When V naught is half V max, Km will become S naught. So when V naught is equal to half V max, Km will become S naught. To solve this equation, what you have to do is you substitute V naught with half V max in the Michaelis-Menten equation. All of you, I'm asking you, all of you, take one paper and pen. Take one paper and pen. Write this equation. V naught is equal to half V max. And you have to solve how Km will become S naught. If V naught is half V max, how Km will become S naught. For that, I'm giving a clue to solve this equation. Substitute V naught with half V max in the Michaelis-Menten equation. That means you take the Michaelis-Menten equation, substitute V naught with half V max. Don't touch remaining things, V max or S naught or Km or S naught. You don't touch that. Only V naught you substitute with half V max and derive and show me Km will become S naught. If you have a doubt, you can unmute and ask. So you take the slide, one pen and paper, write this Michaelis-Menten equation, V naught is equal to V max into S naught divided by Km plus S naught. Then you write on V naught is equal to half V max and substitute V naught with half V max in the Michaelis-Menten equation. Then you solve and show me how Km will become S naught. That means how Km will become substrate concentration when velocity of reaction is half V max. What you have to do is you solve it and take snapshot of it and put it in the first year group. You solve it, you take your own time, you solve it and put it in the first year group. We'll see how many of you can solve. What is your mathematical skill? Very simple logic. A cross multiplication is enough. So you will get a final equations. Just try this, 2 or 3 minutes. If you are not mathematically good, or if you hate mathematics, or you cannot solve this, you keep quiet. I'll explain you how to do it in the next slide. But who are interested to solve this, take it as a challenge, solve this, and take a snapshot of it and put it in the first year group. So it's very simple. You just substitute. It's a simple mathematics, basic mathematics. You are not going to substitute anything on the numerator. You are not going to substitute anything on the denominator. Just V naught you are replacing with half V max. Then you do the cross multiplication. Then you do the simple mathematics, logical mathematics. So you will get Km is equal to S naught. That's very, very important. You can follow any steps. So I will be solving through one step. You can follow any steps and you will finally the thing in mathematics you should get. You should tell that Km is equal to S naught. That's all. Can anyone unmute and tell whether you are doing it or not?
Sir, we are sent in the group, sir.
Yeah, pardon? Searching
we
for
have
the
sent
pen.
the snap on the group, sir.
Pardon?
We have sent the snap in the group, sir.
Okay, you done it?
Yes, sir.
Yeah, okay. Then it is good. Who have finished, okay. For remaining who are struggling, yeah, I will show that slide how to solve it. This is my way of solving because I am also not so good in mathematics, but this is my simple way of solving. There are many, n number of other ways you can solve it. So this is the way. What I'm doing is, I'm substituting V naught is equal to, instead of V naught, I'm taking it as half V max. Then I'm doing the cross multiplication. When I do the cross multiplication, I will get V max into Km plus S naught is equal to 2 V max into S naught. I hope it is correct, my mathematics. If I am wrong, you can put it in the chat box, I am wrong. So the simple cross multiplication I'm doing. So when I do like that, if I solve further this one, so I'll get V max into Km plus V max into S naught is equal to 2 V max into S naught. If I solve this further, what I'm doing is I am subtracting 1 V max from 2 V max. From this V max, I'm taking to the right side, so I can subtract it. So 2 V max minus 1 V max it's my simple way of explaining mathematics. 2 V max minus 1 V max, so it is V max into S naught. Right. So one side it is V max into Km, another side it is V max into S naught. What I'm doing is I'm now cancelling both the V max. Because in mathematics it is possible, right? We can cancel each other. So you will get Km is equal to S naught. So you are just substituting V naught is equal to half V max. You are doing the cross multiplication. Then you are solving further one step. That means again multiplying V max with Km and S naught. So then you are subtracting V max to V max from 1 V max. So you will get a V max. You are cancelling V max both the side. So you will get Km is equal to S naught. This is a simple way you can solve it and you can find it out. And it's important. Okay, sometimes they'll ask for 5 marks also. This simple question. If V naught is equal to half V max, how Km will become S naught? For a biological students, it's a big mathematics. So they'll ask for 5 marks also. You should be careful while solving this simple equation. So another way I'm putting here. Next slide. You can see this is another way. What they have done is Michaelis-Menten equations. You just substitute half V max. You can solve this way also. If you want to just have a look how they have solved. So this is another way of solving the same thing. But finally, they are also getting Km is equal to S. You don't worry whether it is Km is equal to S or Km is equal to S naught. Why always you write S naught? Why I'm telling S naught is the initial substrate concentration. So you better mention S naught and better mention V naught. You don't write S and V. Here when I copy some internet material, that is pictures, there they might have mentioned it as S naught, S, but you take it as a S naught itself. So this is another way. This is my way of solving it. This is another way of solving it. You finally, in all the way, in mathematics, any format you follow, finally you will get Km is equal to S. If you are not understood, you can ask me. I'll explain you again that slide at the end. We'll go one more step further. See, if we have an equation like that, V naught is equal to V max into S naught divided by Km plus S naught, Michaelis-Menten equation. If you plot a graph of V naught versus substrate concentration, that means as you add the substrate concentration, how the velocity of a reaction is going. So you will get, this is called Michaelis-Menten graph for first order kinetics of enzymatic reaction. This is Michaelis-Menten graph for first order kinetics of enzymatic reaction. The same graph you can use it in case of substrate. What is the effect of substrate concentration on the enzymatic reaction? Same graph I'm using it here. Here you can see it. There is a Vmax at the top. Here you can see one Vmax. That means a reaction velocity versus substrate concentration you are plotting. So you are getting a rectangular hyperbolic curve. This curve what we call a rectangular hyperbolic curve. I hope you know what is hyperbola, parabola, straight line and all. I hope you remember in PUC what you studied, hyperbola, parabola, straight line and all. So then we'll go to what is straight line, what is parabola and all to differentiate between hyperbola. So here you can see the maximum velocity at the top. There is a one line which represents the maximum velocity. How we are getting maximum velocity means when you add substrate and substrate and substrate, At the final stage, it forms a linear pattern because enzymes are fixed, number of substrates are more. It requires more time to convert this substrate into products. So what happens? It forms steady format. So you will reach Vmax. If you take half of that Vmax, so that is Km. That's what we solve that equation. When V0 is half Vmax, Km is substrate concentration. This x-axis is substrate concentration. Y-axis is velocity of a reaction or V0. When V0 is Vmax, Km is S0. So you can derive Km. So at particular substrate concentration, so how to tell if someone asks what is Michaelis Menten concentration? This is when substrate concentration is Michaelis Menten constant. That means when velocity of the reaction is half. When velocity of the reaction is half, the Km will be equal to substrate concentration. The way you can tell someone like how velocity of reaction and Michaelis Menten equations are connected, how you can connect it. So this is the problem in this case. See, Michaelis Menten has done one equation and he found out, he plotted V0 versus substrate concentration and he derived an equation. And what is the problem here? It is a rectangular hyperbola. If you add anything to this, you will get a steady line. You don't get a straight line, you will get a hyperbolic curve at maximum velocity, with maximum velocity. But you just imagine you have a 10 substrate, but you want to extrapolate it for, theoretically you want to extrapolate it for 20 substrate or 30 substrate. It is not possible with the help of Michaelis Menten equation because his equation and his graph has got its own limitations. When it reaches a particular level, you cannot go further. So there is another modification of this graph that I'll explain you in the next slide. So I hope you got this graph. This graph is also important. They may ask Michaelis Menten equation with this graph for 5 marks, or Michaelis Menten equation only for 2 marks, or this graph only for 2 marks. So very simple graph. When you plot V0 versus S, you will get a rectangular hyperbolic curve with Vmax and Km. You have to mention all these things: Vmax, half Vmax, Km, V0 versus S0. You should know what is y-axis, what is x-axis. So when you plot, you will get a rectangular hyperbolic curve. To differentiate this hyperbolic curve, I have put one slide which shows how. Here I have put a straight line. I hope you can differentiate between a rectangular hyperbolic curve and a straight line. A straight line is straight, and a rectangular hyperbolic curve is a hyperbola. So straight line, you can extrapolate it any direction. You pull it to 1 kilometer, no problem, it will go like this. But here in hyperbola, it is not like that. You pull it, it forms a steady pattern. It won't go in a linear scale like this. Then only you can measure the enzyme activity. But straight line, it is possible. That's why they modified this equation in the later part. That I'll tell you how they modified this equation. So this is a straight line. Straight line means what? Y is equal to mx plus c, or y is equal to mx plus c. A slope and intercept will be there. This is straight line. Then what is a parabola? Parabola is y is equal to x square plus bx plus c. So now if you look at a line, straight line, there is a parabola and there is a hyperbola. I hope you can differentiate between 3 types of graphs: a parabolic graph, a hyperbolic graph, and a straight line graph. Each graph has got its own significance, but when you consider enzymatic reactions, the straight line has got a more significance. That's why they modified this equation. Theoretically, extrapolation is not possible with the help of rectangular hyperbolic curve. So they modified this one into a straight line. How to modify it and who modified? That's a very important thing. Next part is also so important for us. We'll go further. So that is a line weaver. Line weaver Burke is a scientist. These are the one who modified this equation and converted the entire equation into a straight line. And here also I'm giving one what you call small exercise for you. You take again a sheet of paper. Let us make this class as a little interactive, otherwise it will be boring for you all. So because it is a little of equations, if we get a class again in regular college days, then I will repeat it. Don't worry about the mathematical part because there is no other way to do it. So we will do it again. You don't worry about it. But now for a time being, you just write down Michaelis Menten equation. V0 is equal to Vmax into S0 divided by S0 plus Km. You don't worry whether I mentioned here S0 or S. You can either write S or S not. Anything you can write. You just write down the equation. Can anyone unmute and tell me whether you written? Whom I'll ask? I'll ask Raghavendra. Hello, Raghavendra.
Yes, sir.
Yeah.
Hello.
Have you written that equation?
Yes, sir.
Yeah. Good. 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 So now what you have to do is you take that equation and in reverse this equation. That means you make it ulta. So when you make it ulta, reverse this equation, what you will get? You will get V naught will become 1 by V naught, and in the next right side, what happens? Whatever things are there in the denominator will go to numerator. Whatever things are there in the numerator will come down to denominator. So you just make it ulta. Let me see. V naught will become 1 by V naught. Next is Km by V max into S plus or S naught. Next is S naught or S divided by V max into S. I hope it is correct. All of you have written. Solve this. Next, you further solve it because what you can do is when you do it like this, there is a Km, you just make it ulta. S naught, you make it ulta. Here in the right concentration of in the denominator numerator, you can cancel it. Mathematics, it is possible. You just cancel both S. So you will get this equation: 1 by V naught is equal to Km by V max into 1 by S plus 1 by V max into S, or Km by V max into 1 by S plus 1 by V max. If you look at this equation, this is in the format of straight line. Y is equal to mx plus c format. You just have a look. Y is equal to mx plus c. That means there is a slope, there is an intercept. There is a slope, there is an intercept. I hope you are getting it. It's a very simple mathematics. There is a slope and there is an intercept. It is y is equal to mx plus c is a format or the equation for a straight line. So what this Lineweaver work has done, they just modified or they took this Michaelis-Menten equation. They just inverted it, just made it ulta. So when you make ulta, what happens? You are getting, you can solve this or you can reform this or rewrite this equation in the form of y is equal to mx plus c. If you write it in y is equal to mx plus c, you can plot the graph. Here, what is y-axis? Y-axis is 1 by V naught. What is x-axis? 1 by S or 1 by S naught. If you plot 1 by V naught versus 1 by S naught, you will get a straight line like this. You will get a straight line like this. I mentioned in the red this thing, you will get a straight line. What is the benefit of straight line? Straight line you can extrapolate. You can extrapolate to any extent. So, what is a slope? Slope is m, right? M is a slope. C is a intercept. So what is m? M is Km by V max. You can see here. Km by V max is the slope. Km by V max is the slope. I hope you are getting. Km by V max is a slope and intercept is 1 by V max. That is C. You can see here C. C is 1 by V max. So 1 by V max is C. So it is intercept and slope is Km by V max. If you plot 1 by V or 1 by V naught versus 1 by S or 1 by S naught, so you will get a straight line and where it touching the x-axis. So here it is, see, when you plot a graph, so there is a left side for a graph, there is a right side for a graph. So from the zero, this is the zero. From zero, if you go to right side, it is increasing. From left side, if you come near to zero, that is increasing. I hope you know. From negative side, if you are coming to which one is a big number? It is a minus 10 is a big number or minus 2 is a big number. Can anyone unmute and tell? Whom I'll ask? I'll ask Soumya. Whether minus 5 is a big number or minus 1 is a big number. Soumya, can you unmute and tell me?
Yes, sir.
Yeah, which one is a big number compared to 0? 0 is the
Zero.
biggest number. Consider 0 is the biggest number, and you take -1 and -5. Which one is the big number?
-1, sir.
Yeah, good. -1. -1 is the big number. So in the minus scale, what is happening when you go from 0 to -1, -2, -5, -100? It is decreasing. But in case of positive scale, what happens when you go from 0 to 1, 2, 3, 4, 5? It is increasing. So that's the important thing in enzymology. When we plot Lineweaver Burke plot, if the graph is the straight line is coming closer to 0, that means it is increasing. So here you can see, instead of Km, here you will get -1 by Km because it is the minus side. So it is minus. It is not Km, it's inverted graph. So it is 1 by Km. You can see here, in a normal equation, it was Km. It is -1 by Km here, and slope is Km by Vmax. So they may ask this graph also for 2 marks, or else this entire equation with this graph for 5 marks. So this equation they may ask for 2 marks, or this graph they may ask for 2 marks. So it's very important, one very simple too. If you know what you call Michaelis-Menten equation, there you have to reverse this equation. So you will get y is equal to mx plus c. You should know what is slope, what is intercept. I'm not going to tell you what is slope and what is internet. When you get a free time, you just please search in the internet, or maybe in the mathematical book if you have PUC book, see that what is slope and what is intercept. So you will get y is equal to mx plus c. So if you plot y is equal to x, you will get this graph 1 by v equals 1s. It's a straight line. So there is a slope called km by vmax. There is an intercept called 1 by vmax. And why I'm telling all these equations are important for our next study is next inhibition will come. There also we are not going to solve any equations, but we are going to study a bit about a graph. That's all. So it is -1 by km. That much thing you should remember. I hope in this class we studied mainly a Michaelis-Menten equation, that is V naught is equal to Vmax into S naught divided by Km plus S naught. Then we studied how if V naught is half Vmax, Km will become S naught. That solution, so that equation we solved. Then we plotted a graph V naught versus S naught. So we got a rectangular hyperbolic curve. So there we could clearly identify when V naught is half Vmax, Km is S naught or S. So, but the problem there, it is a rectangular hyperbolic curve. Theoretically, you can't extraplot it. So if you want to theoretically extraplot, we need to modify it. Who modified it? Lineweaver Burke are the one who modified it. What they've done is they took this equation, they inversed this equation, and they found out, they converted this in the form of y is equal to mx plus c. So you got a straight line. From there, you can extraplot it, and you can find out exactly what is the rate of enzymatic reaction at the theoretical scale also. You just imagine you could not determine more than 100 substrate. So you wanted to determine 200 substrate. Theoretically, you can add 100 more substrate and you can determine what is the possible enzymatic reactions. That's called mathematical modeling, right? The same thing what they are doing in coronavirus. If they're telling today, if we are getting 10,000 cases per day in Karnataka, how it will become a 2,500,000 case or 2,50,000 cases in next 10 days, or maybe next 100 days, or by when we will reach a peak, or something. How they are doing a mathematical model, because the same prediction you can do it here also if you get a straight line. But if you get any other parabolic or hyperbolic curve, it is not possible, because once it reaches a particular stage, it forms a steady pattern. Then there is a further linear scale movement won't be there. That is very important. Linear movement is needed in case of extraplot theoretical and find out what is the effect. So these are the things what we studied. Next important theory part is there. One small slide that's very important. What is this Km? What is this Vmax? Here important thing, and you should remember this. Km is that concentration of a substrate at which half the active sites of the enzymes are filled. Sometimes they will ask for 2 marks. What is Km, or what are Km value, or what is Km value? Km is that concentration of substrate at which enzyme has got an active site. Half of the enzyme active sites are filled with substrate. If half of the enzyme active sites are filled with substrate, then you can say it is the Km. So what is Km represents really? Km represents the binding affinity of the substrate for the enzyme. That means Km tells how strong enzyme and substrates are interacting, whether they are interacting very strongly or whether they are interacting very weakly. If they are interacting strongly, it can form a better product in less time. If they are interacting weakly, it can form less product in a more time. So the Km represents strength of binding or affinity of the substrate towards the enzyme. First thing, Km is the concentration of substrate at which half of the active sites of the enzymes are filled. And second thing is Km represents the strength of binding. Binding affinity also you can write, or just binding or affinity also you can write. You can put it together also, no problem. So it represents the affinity of the substrate towards enzyme. So next two points are very important. If lower, the Km value is less, the affinity of the substrate towards enzyme is high. That means they are acting in a vice versa. The low Km means high affinity. High Km means low affinity. That means if affinity is high, Km is low. When Km is high, affinity is low. So I hope you are getting two things. The Km represents the affinity of the substrate towards the enzyme. So lower the Km value, higher the enzyme affinity. So higher the Km value, lower the enzyme affinity. That thing you should remember. In most of the time, students will make when they write it in the exam. What mistakes they'll make? So they write it higher the Km, lower the enzyme. Is it true? It is correct. You do it in any way, you will get a correct answer. I'm telling you, write it higher the Km, you have to write lower the enzyme. You write lower the Km, you write higher the enzyme. That means you don't make that kind of mistakes in the exam. I just told you will make a mistake. That means you sometimes you think higher the Km, lower the value is mistake. No, it is vice versa. You do anything, you don't make any mistakes here. That's what I'm telling you. You can confidentially write, with full confidence, you can write it how the Km have affinity changes. Lower the Km, higher the affinity, higher the Km, lower the affinity. If you write low, you have to write high. If you write high, you have to write low. I hope you got the significance of Km now. Next is what is the significance of Vmax? Why the Vmax, initial maximum velocity, is so important for us? So because this initial maximum velocity will give us an idea of turnover. Reveals the turnover. Turnover means, like business turnover, they tell in case of turnover, what is the amount they are getting in a turnover, that particular business year. So same thing is March, the April 1st to March 31st, how much money they are getting. So that's what you call turnover. Same thing is there for the enzyme. What is enzyme turnover? Enzyme turnover means number of substrate molecules converted to product per enzyme per unit time. Per enzyme, per unit time, how much substrate molecule can be converted into product. If they can convert more substrate molecule, that's a good enzyme. If they convert less substrate molecule, then it is a bad enzyme. If it is a good enzyme that convert more substrate. So efficiency of the enzyme. So you are just imagine you are producing some products at the industrial scale. You look for enzyme which has a more turnover number. So number of substrate molecule converted to product